EIGRP is also 100% loop-free routing protocol. It does that by calculating distances using the feasible distance and the administrative distance. It also uses protocol 88, using TCP protocol 88, or excuse me, 6 and 17, and it uses its own transport protocol of 88 in order to send and receive information from the neighbors or trying to establish neighbors. As you can see on your screen right now, we have a lab set up. We have several different routers. A lot of them have Looney Tunes names on them. Easy to remember in that way. First thing I want to do is go to the frame relay section of it, which is Daffy, Bugs, and Pepe, and we're going to set that up. We're going to enable EIGRP on those routers right now. So let me begin with Daffy. I always advise you that the first thing you do when you're working on a router is to show IP interface brief. That's going to give you a lay of the land to see what's going on. So in this scenario, since only the loopback address and the serial address is configured on this router, I can do a wildcard mask, which will enable everything on this into the EIGRP system. In order to get into EIGRP, you're going to send the basic commands to the router, which is a router, EIGRP, and the ASN number. That number could be anything from 1 to 65,000, I believe. Let's check. Yeah, 65,535. So we use number 1. One common command that everybody types right after they enable the EIGRP process on the router is the no summary, no auto summary. What this command actually does, if I can spell it right, what this command actually does is sends classless information across the routing protocol. I have a question. What's the difference when you can use router EIGRP word? I'm not sure if you can use router EIGRP word. It has to be followed by an actual number, Lee. As you can see on the screen. Can you actually see the screen? Is it big enough so you can actually see it? Is the font big enough? All right, cool. I could try it, but it's not going to give me anything. As you see previously, router, EIGRP, and if I put the question mark after it, you're going to see it's going to tell me a time system number. Put in Lee, for example. As you see, it's going to give me incorrect input. It has to be a number there. That would be yes. That would be something completely different. So we're going to go with number 1 for now, and we're going to again make sure that the no summaries enable. We're going to actually put the 2 interfaces into the EIGRP process, and I'm going to actually type that out because I really dislike doing wildcards. The reason before that is you want to make sure exactly what you're putting into the network. Command. What did I do on that? Forgot a dot. You want to make sure that whatever network that you're putting into whatever protocol, you're putting on that specific network. Even though that there's no other networks on here right now, best practice always just to focus on whatever network or subnet that you're actually working on and make sure you're bringing that up right now. Show run section router. As you can see right now, EIGRP is configured on this router itself. I have the loopback interface on here, which is 1.1, and the actual serial interface, which is 172.116.123.x. Well, this is router 1, so it's going to be router 1. I'm going to move over to the Pepe router right now. No, I'm not actually recording this one right now. I'm going to probably do that the next time. Right now, I'm going to add the serial interface into the EIGRP process. So what I'm going to do is, once again, config T, get into enable mode, router EIGRP 1, put the no auto summary on, put in the specific network I actually want on in the EIGRP process at this time. So it's going to be network 172.16.123.0.0.0.255, and I'm going to put the loopback address in there. 2.2.2. First thing you'll see that an adjacency has been formed right now, and it's going to actually show you the actual router it made an adjacency with. At any time, you can always go back and look at the neighbor table by doing show IP EIGRP neighbors, and it'll show you that the neighbor that it's connected to. It'll tell you the uptime, the round trip timer, and a sequence number. These are crucial numbers to look at when you're debugging EIGRP problems. One thing that should always be on 0 is this queue count right here. Whoops. If you have that queue count increases by any digit, number, or whatever, that means you have a backup in your EIGRP, in your table, in your routing table. You can have a route that's stuck in active or something like that. Something's not configured right. You want to investigate that a little bit further. In order to check out that in more detail, you're going to do the show IP EIGRP traffic. That's going to give you a breakdown of the hellos, the updates, the queries, the replies, the acknowledgements, even your SIAs. So as you can see, everything on this end is looking pretty good. You're sending a hello, you're receiving a hello. You send some updates, you receive the exact amount of updates. And you're also followed by acknowledgements. The acknowledgements is to let the other router know that whatever information it sent over, I see it, I have it, and I can tell you about, I can share it or reach that sort of the network. At this point, we're going to do the show IP route. And we will see that router 1 and router 2, which is Daffy and Pepe, connected to each other right now. Daffy's loopback address is 1.1.1.1, as you can see. It's also highlighted right here. I'm highlighting right here. It's showing you that it's going out the serial interface to get there. First thing you should always do when you get adjacencies with any router is ping. So you don't know how many times you could see something in a routing table and it just won't get there. I'm going to show you an exact example of that today. So far I can ping Daffy's loopback address, so they're full adjacencies right now. Now we're going to move over to bugs. There goes bugs. Bugs is over here. Show IP brief. You're going to see that there are 3 interfaces up here. At this time, we're just going to put the serial interface, which is 172.16.123.3, and the loopback address, which is 3.3.3.3. Big T, 1, auto, network. Second. Okay, now we've entered that into the EIGRP process of number 1. As you can see, the neighbor adjacencies that actually came up. It's made a neighbor adjacency with router 1, which is Daffy. So you can do the show IP EIGRP neighbors, and it'll show you that it actually sees Daffy sitting over there. Show IP route, show information that it actually learns. So far it's actually learned about Daffy and not Pepe. All right. Now, let's say we want to get traffic that's from Pepe, which is over here, to Bugs Bunny, which is over here. Now, let's try to ping it. Let's just to see if we can actually reach that. So if we ping the IP address of 172.16.123.2, you'll notice that the pings actually die coming from router Bugs. The reason that is because there's no adjacency between Bugs and Pepe directly connected. Since this is going over a frame relay network, you might remember one caveat in actually with frame relay. It's the split horizon rule. It's saying that if you learn a route out of one way, you cannot re-advertise that route out the same way. But there are workarounds around that. Our basic workaround around that would be to configure Daffy to enable or disable split horizon. So I'm going to go over to Daffy now. And just to show you that I have connectivity with Daffy between Pepe and Bugs, I want to just show IP EIGRP neighbors. And it will show you that it has 2 actual neighbors that one is Pepe, which is 172.16.122.2, and Bugs, which is 172.16.123.3. You can actually see in the routing table that from Daffy, I have full reachability to 1, loopback 1, loopback 2, and loopback 3. I can ping them now. So that's number 2 and number 3. Now, in order to alleviate the problem with split horizon, what we have to do is configure on the interface the no split horizon rule. Big T interface 0/01. No. Split horizon. You also have to indicate what EIGRP number or autonomous system you're running it on. So you have to put it in. So we're using number 1, so I'll put that in there. And you can see a CR, which is a return, so put that into there. You'll see the connection drop for a second and resync up again. Now, if you go over to a specific router like Pepe, and we do the show IP route, you'll see it has Bugs's loopback address in here. Now, like I was saying earlier about just because you have something in a routing table doesn't mean it's necessarily reachable. So once you configure something, you should always ping it. So in this example, we're going to ping 3.3.3.3. So as you can see, there is no reachability still to that actual route. The reason behind that is because of how frame relay is actually set up. So if you take a look at the configuration, show run interface S0/0. You'll see that there's only one frame relay command, frame relay map IP address in here. So it only knows how to get to that one destination. It's not being forwarded from Daffy to any other place. So, for example, if you want to get to the other side, you have to manually configure a frame relay map command using the same Delcy number that's already configured on your serial interface connecting back to Daffy. Maybe 1 minute while I do that. Interface /0. Frame relay map. 172.16.123.3.2.1. That has to be done on both sides in order to enable this magic to actually happen. So I'm going to go over the bugs, and I'm going to enter that same command. Now that's actually configured. So we're going to try the ping one more time now. So we're going to ping 2.2.2.2, which is the loopback address of Pepe. And as you can see, that's successful and that's getting through. So now we have traffic that's going all the way around the network. Each endpoint is able to reach each other endpoint. All right. The next part about this is we're going to configure, let's see, we're going to start configuring the rest of the network, and we're going to play with metrics, and we're going to play with variants today. So I'm going to go over bugs, show IP interface brief. Show I'm checking EIGRP to make sure I have all the networks in there now. So I'm going to actually put the fast Ethernet 00 interface into bugs, and I'm going to configure the rest of the network so everybody else has full connectivity. And we'll go over to Mugsy. At this point, I'm just going to put a wildcard in here just to get every interface in there. Okay. Elmer. Auto. Urban. And Foghorn. Listen, somebody. 1, 2, 3, 4. Where is 5 and 6? Elmer. Brief. Route 5 and 6. Something's wrong with Elmer here. Great. This is since I ran into this little problem here, a bit of an issue with connectivity between Elmer and Pepe. Let's see, 5 and 6, 5 and 6, 5 and 6. Not getting any hellos from Pepe. So let's go take a look at Pepe. Section router EIGRP. Pepe doesn't have the network in there. EIGRP1 network 172.16.25.0.0.0.0. Pepe should have a new adjacency. No IP address on there. What's that sure IP address? 2.16.25.2. No shit. Now we should have a new adjacency. There we go. So now if I look at the furthest most router, like Daffy, and if I do a show IP route, I should have a route to everybody. I test that easily by making each router have its own adult IP address. Why is that a /8? It should be a 24. So I have connectivity to routers 1, 2, 3, 4, 5, 6, and 7. We're going to talk about, the next part about this, like I said, we're going to talk about the topology tables, variants, and simple other commands. The best way to do a lot of this stuff is to use very low metrics. So that way when you look at something like IP, show IP, EIGRP topology, instead of having such a huge feasible distance and feasible successor numbers, we're going to use extremely low metrics in order to use numbers that we can easily add up and count with. So when we go to, like, for example, router Mugsy, and we do show IP route, instead of having these godforsaken long numbers, we can have them down to short to something that we can all use. The easiest way to do that, this is something that should be done just in the lab and not in production at all, is change the metric weights. Protocols, show IP protocol. Here are a list of the default EIGRP metric weights, the K values. The first one is the bandwidth, second one is the delay, third is the load, reliability, and the last one is the MTU. Unfortunately, using GNS3, you are not able to really configure all of these in a proper manner. So I like to use, you can't change, can you change the weights to prefer route? Yes, you can change the weight to prefer route. But we're going to use very simple ones in order to do that right now. So what I'm going to do is also I'm going to configure the rates, configure the weights. I'm going to use that under the default router command. So it's going to be metric weight 0 for bandwidth, 0 for that. We'll do 1 delay. And you have to do that in all the actual routers. Now, as you can see, I've with everything reconverged, and I have much lower numbers to actually work. This is a poor example because it's a serial connection. Let me use Mugsy to actually do this. Show IP, EIGRP topology. All right. Now that we have lowered metrics, we're able to manipulate routes a little bit easier. How do you verify the weights? If you change them, all you have to do is these show IP protocols. Since EIGRP, show IP protocols. Since EIGRP is the only thing that's actually running right here, and as you can see, the EIGRP metric weights have been changed. I'm only using the delay, which is K3, in order to make changes and things of that nature. Now, we're going to do a little bit of changing the routes and how they actually are in the routing table. I'm going to actually use like router Mugsy here. He's in the middle. And let's trace a route to the loopback address of number 1, Daffy. As you can see, it's going to go over the case over to Pepe to get to Daffy. Let's say we do not want to use Pepe as an influential weight. We can do one or two things. We can change the delay, we can change the bandwidth, and we can change it using route maps. Today we're going to just do it with the bandwidth command. And what you're going to do with that, the easiest way to influence the bandwidth is actually go to the interface itself. So in this case, it's F0/1. And you're going to do bandwidth. And we're going to give it some ridiculously low number. But before I actually do that, I want you to show interface F0/1. And it's going to show you actually the default bandwidth is actually set. Keep in mind, by changing this bandwidth value, you're not actually changing bandwidth of the link. You're just changing it for the calculation. So bandwidth 50. Interface F0/1. Bandwidth. It's best advised to do that on both sides. So we'll go over to Pepe. Interface F0/1. And as you can see now, the bandwidth has actually changed to 50, which is ridiculously slow. On both sides. On both. So now, from Mugsy, if I did a trace to 1.1.1.1, oh, still going up that way. What's wrong there? Oh, I forgot. GNS3, when you change everything to 0, you have to actually use delay instead because you actually just disable that on the interface. So in this case, we'll just do it using the delay. Config T. Terminal interface 0/1 delay. We'll make it some ridiculously number, 40,000. And we'll do it on the other end as well. Mugsy. Pepe. 0/1. So we do a trace to 1.1.1. So this is not very metric. What is wrong here? What is wrong here? A second, 10 more seconds. We're going to look on bugs. 0/0. It's 20,000. And those are the bugs. Interface S0/0. It's a lot lower. Let's take a look. It's a high metric. 1024, 64,000 feasible success rate. And if, let's see, 2 is going that way, that's going that way, that's going that way. Bugs. _123, lower distance. 64, please go on this distance. 64 distance.